Hello, Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to express my gratitude for the honor and opportunity to present our research findings at the Borobudur International Symposium 2024. And our research title is Enhancing Proton Conductivity in Direct Methanol Fuel Cell Membranes, DMFC, using sulfonated polyether dope aluminum oxide composite materials. Okay, let me introduce the author's identity. The first author is myself, Muhammad Fahmi Hakim, SDMT. I am from Chemical Engineering Department, Universitas Singapura Bangsa Karawang. The second author, Insinyur Nur Hidayati, PhD, from Chemical Engineering Department, Universitas Muhammadiyah Surakarta. The third, Najimuddin Fauji, SSC, MSc, from Physics of Science, Universitas Singapura Bangsa Karawang. And the last, Dr. Eri Widianto from Physics of Science, Universitas Singapura Bangsa Karawang. Okay, let's join and enjoy our presentation. Okay, ladies and gentlemen, this is a table of content about my presentation today. The first background, problem formulation, research objective, method and experimental design, research result, and conclusion. Okay, let's begin. Okay, ladies and gentlemen, natural resources are the main source of energy, but their availability is being rapidly depleted. Renewable energy is the most valuable alternative to address energy scarcity. An example of an absolutely effective renewable energy is hydrogen energy. A fuel cell is a tool that converts hydrogen with carrier energy into electricity. Okay, ladies and gentlemen, this is working principle of fuel cell. Okay, a fuel cell is generator that produces electricity through an electrochemical process by combining hydrogen and oxygen to produce electricity. Okay, many types or various about fuel cell, but DMFC are a type of proton exchange membrane fuel cell that use methanol and promisingly. The common membrane or proton exchange membrane that used in direct fuel cell is Nafion membranes, but the Nafion membranes is very expensive and methanol crossover. How about other membranes? The other membranes are mostly low conductivity. So as a student, as a researchers, we must thinking together to solve this problem. And in our research, we combine sPEEK or sulfonated polyether with aluminum oxide. Okay. What is PEEK? PEEK is polyether is an aromatic polymer that can be used as a membrane in fuel cells because it has the useful properties of chemical resistance, then heat resistance, and mechanical resistance. Okay, ladies and gentlemen, this is objective of research. Generally, this research aims to create a sPEEK-based membrane to be applied to the MFC fuel cell. In particular, the study will examine the process of making a composite membrane, sPEEK aluminum oxide, to be applied to the MFC. The second, effect of aluminum oxide concentration on the performance of the MFC, about water uptake, swelling degree, morphology, methanol permeability. And the third, effect of sulfonation process on the performance of the MFC, water uptake, methanol permeability, ion exchange capacity, and FTER. Okay, this is the method and experimental design. We use charts 3, 6, and 10% of aluminum oxide as a filler on the matrix composite, and then 3 times repetition. Okay, independent variable, chart of aluminum oxide, and then dependent variable is a characterization, water uptake, methanol permeability, ion exchange capacity. Okay, next about procedure. there are three procedures: sulfonation, composite membrane making process, and characterization. Okay, the sulfonation. Okay, the first step of sulfonation is preparation. First, we must drying polyether decaton 100 degrees Celsius and vacuum pressure on the oven, and then react it with high concentration of sulfuric acid for hours and 75 degrees Celsius, and then stop reaction with poured into ice water. Yeah, we can see the pictures. This, and then after this, wash until natural pH, and we get sulfonated polyether terketon. Okay, the second step, manufacture of composite membranes. Okay, the sPEEK before we dissolve with the MFC, the metal acetamide, and aluminum oxide, mixing together and then coating on petri dish. After this, heating, and we can get composite membranes. Okay, characterization after casting. There are five kinds of characterization. First, water uptake and swelling degree, then methanol permeability, ion exchange capacity, and then SEM and FTIR. Okay, next about result and discussion. Okay, the first about water uptake and swelling degree. Okay, the addition of 3, 6, and 10% of aluminum oxide filling material improve the water uptake of the membranes. We can see in the pictures, in the figure, the increasing during the filling of aluminum oxide. And then the addition of 10% aluminum oxide improve this property by 2 until 3 times with value 41.09, and compare with Nafion with value 37%, and compare with sulfonated polyether terketon without filler materials is 20%. And then high water uptake value indicate a high membrane conductivity. Therefore, the membrane will be excellent for DMFC application. And same with a swelling degree. A swelling degree and water uptake is not too different. And then we must know that the cause of water absorption in the membranes and prevented excessive absorption, a condition that might have led to instability in the membranes. Okay, next, this is about scanning electron microscopy. You can see the pictures. There are two pictures. And then the morphology and elemental composition of 10% sulfonated polyether terketon with aluminum oxide membranes were examined via scanning electron microscopy. And then we can see that the 10% aluminum oxide was mixed, forming a composite membranes. We can see in the pictures. This is like aluminum oxide in the matrix of polymer polyether terketon. SEM revealed the morphology and elemental composition inside the membranes, which in turn reflect the membrane's absorption ability and proton conductivity. Then SEM we can make sure about the highest proton conductivity with FTER, about the functional group. Yeah, we can see together many functional group identified from these membranes. Okay, the FTER characterization of the 10% sPEEK aluminum oxide membrane are presented in this figure, and then the wave number and intensity of the 10% sPEEK aluminum oxide membranes also can we display with table, especially But in this presentation, I just show you with this graphic. The addition of aluminum oxide caused the peak wave number to reach 1217.03 per centimeter. Both SAM and FTER analysis revealed that aluminum oxide enter the membrane with FTER analysis demonstrate the water and methanol absorption ability of the membrane regarding water uptake, proton conductivity, and methanol permeability. Okay. And then about ion exchange capacity. Okay. A high ion exchange capacity indicates a high proton conductivity. You can see in the graphic with the adding of aluminum oxide on the sPEEK membranes that are increasing ion exchange capacity from 2.346 to be 2.686 milli equivalent per grams. Okay. This temperature was set close to 80 degrees Celsius. Herein, because the membrane may become unstable beyond this temperature, the ion exchange capacity of 3, 6, and 10% sPEEK aluminum oxide was displayed in this graphic. Respectively, the increase in ion exchange capacity was due to sulfonation, during which aluminum oxide filling materials were added. Subsequently, the filling materials were sulfonated and the number of sulfonic groups in the membranes increased. The highest ion exchange capacity was obtained from the 10% sPEEK aluminum oxide membranes, and result showed that 3, 6, and 10% sPEEK aluminum oxide are applicable to direct methanol fuel cell. Okay, from all of characterization, we can make a conclusion. The addition of 10% aluminum oxide to sPEEK increased ion exchange capacity by 2.68 milli equivalent per grams, water uptake by 41.09%, and solenoid degree by 41.96%. Therefore, the 10% sPEEK aluminum oxide membrane has potential application in direct methanol fuel cell. Okay, thank you. This is my presentation, and Assalamualaikum warahmatullahi wabarakatuh.